Hey everybody, welcome to tutorial 14, where we'll start creating some basic graphical user interfaces, usually called GUI or just GUI for short. GUIs can provide an intuitive intermediate layer between the user and the code, which, as you can probably imagine, is pretty useful in a lot of situations. On the surface, it might not seem like SuperCollider is much of a GUI-capable program, but in fact it's quite richly featured when it comes to creating graphical functionality. In this video, we'll look at a broad overview of some common objects, their essential behaviors, and how to create and manipulate them. I recommend you take a look at the guide called Introduction to GUI, which is a good resource for general information. And within the SuperCollider application folder, there's an examples folder, and within that, a folder called GUI examples, which is another good resource. So, let's begin. A graphical user interface begins with a new window, which we can create with window.new. So, first of all, a very obvious question, where is the window? Well, a newly created window is invisible by default. We can change this using the front message, which does two things. It sets the window's visible attribute to be true, and brings the window forward to the frontmost position. Now, since I'm going to be typing a lot of code, it's going to be useful to have this window remain in the frontmost position, so I'm not constantly switching back and forth between the window and the environment. Windows have an attribute called always on top. And if we ask for this value, we can see that currently it's false. We can change this by setting the attribute equal to true. And now the window remains on the top, and it doesn't matter if it's in focus or not. So whenever you're setting a value for some attribute of an object, as we've just done, there's an alternate syntax. Instead of attribute equals value, we can type attribute underscore and then in parentheses the value. And I tend to prefer the underscore syntax because it allows you to concatenate several methods together into one statement. And I want to introduce this syntax early on because I'll be using it a lot. You can find this syntax shortcut and many others in a reference file called Syntax Shortcuts. You can close the window with .close, keeping in mind that Xing it out with the mouse invokes the exact same behavior. When the window's closed, the instance is permanently destroyed, so we can't reopen the window or otherwise access it. As you can see, front no longer works. So here's a new window, and notice I'm able to string these three methods together. I'm using a multi-line approach because I think that's a little bit easier to read. Now, take a look at the post window here. We've asked for a new window, but SuperCollider returns a queue window. Why does this happen? Well, this behavior is the result of SuperCollider's GUI redirect system. And to help explain what this is and how it works, I'm going to open a help file called List of GUI Classes. So at any point in time, one and only one GUI kit is active. And when the user asks for a generic GUI object, SuperCollider defers to the active GUI kit and returns the corresponding object that belongs to that kit. GUI.current returns the active kit, which for me happens to be Qt GUI. This means that when I ask for a new window, what I actually get is a queue window. Of course, I could ask for a queue window directly, like this, but the problem here is that if I then gave this code to someone using a different GUI kit, this code wouldn't work correctly. As an example, even though a class called SCWindow supposedly exists, we get an error. In fact, in this case, the Cocoa GUI kit isn't even installed. So the bottom line for you, if you're designing an interface, is you should always use the generic names in the leftmost column here, and then let the redirect system handle everything else. And in fact, the Introduction to GUI help file spells it out, plain and simple. We now have two windows open, and they're both named W. This means we've overwritten the variable, and w.close is only going to work on the window that was created most recently. But if you ever find yourself with multiple open windows, intentionally or unintentionally, you can always rely on the class method closeAll. Okay, moving on, let's talk about size and placement. Every graphical object has an attribute called bounds, which determines the size and location of the rectangular space which that object occupies. An object's bounds is represented by an instance of a class called rect, whose 4 arguments represent x position, y position, width, and height, all measured in pixels. If we move and or resize the window, bounds returns a different rect. Specifically, the first two numbers are the XY coordinates of the lower left corner of the window relative to the lower left corner of the screen. The third and fourth numbers are the width and height of the window, respectively. Instead of clicking and dragging, we can alternatively modify the bounds by evaluating code like this. And when we create a new window, we actually have the option of specifying the initial bounds as one of the input arguments. The first argument to window.new is a string that will appear in the window's title bar, and the second argument is the bounds. Then there are a few other arguments which I usually don't bother with, and they're well documented in the window help file. If you want to place a window somewhere specific, but irrespective of any particular screen resolution, then the class method screenBounds is very useful. The method itself returns an instance of rect that would theoretically fill your entire screen. So let's imagine we want to put a 200 by 200 window in the absolute center of the screen. In the help file for rect, we can see a number of instance methods, including width and height. So we can calculate the center pixel of the screen by dividing width and height by 2. But these parameters, in their current state, will put the lower left corner of the window in the middle of the screen instead of the center. So to compensate, we subtract half the width and height of the window from the X and Y position. And this should place a window in the exact center of the screen, regardless of screen resolution. So now we're going to start talking about some more familiar and more functional GUI objects. And to do this properly, I'm going to begin by introducing a class called View. View is the parent class of all GUI objects, including knobs, sliders, buttons, menus. Realistically, any visible element is a subclass of View. The only exception is Window, which is related, but for the most part, its own separate class. And of course, this means that all of the methods defined for View are inherited by its numerous subclasses. And so within the world of SuperCollider GUI, there's a very pervasive and convenient homogeneity. And in plain speak, if you know how to deal with one type of GUI object, you can very easily apply this understanding to other GUI objects. So I'm going to start with a slider, which I think is one of the simplest and most straightforward GUI objects. View and all of its subclasses expects at least two inputs. First is the parent view, which in other words is the visual space on which the object will reside. So this requires just a quick explanation here. Whenever we create a window, the rectangular space which occupies the main part of the window is in fact itself a type of view. In this case, we can see it's an instance of the subclass called QTopView. And this sort of reinforces the fact that really any graphical entity is some kind of view. So for the parent view for our slider, w.view is basically our one and only sensible option here. The second input argument is the object's bounds, so we provide a new instance of rect. And here there's a minor but important difference. When we create a window, the origin of the parent space is in the lower left corner of the screen. But when we place views on a window, the origin of the parent space is actually the upper left corner of the parent view. So here our slider is going to be 20 pixels from the left side of the window, 20 pixels from the top, 150 pixels wide, and 30 pixels tall. So of course, our slider doesn't really do anything yet because we've only specified the parent view and bounds. We will make the slider do something, but first, here are a few very basic behaviors of views. The parent message returns the instance of the parent view, in this case, the top view that occupies our window. And a view will respond to the children message by returning an array containing all the views which have been placed on it. In this case, an array containing one slider. Children is a convenient way to address every view within a given space, rather than having to address them all individually. Views can be hidden and unhidden by setting the visible attribute to be false or true. We can modify the bounds of a view just like we modify a window's bounds, keeping in mind that the first two values of the rect are with respect to the upper left corner of the parent space, not the lower left corner. So here I'm moving the slider farther away from the corner, and here now I'm lengthening the slider and making it a bit thinner. The enabled attribute determines whether the user can interact with the object. When it's false, the mouse no longer has any effect. And the method remove will destroy the instance, after which it becomes inaccessible. And to reinforce this, we can see that now the array of children is empty. All right, we'll start fresh once again, and this time I'll show a few syntax shortcuts that might make your life a little easier. In practically every case, not just GUI, you can omit .new, and SuperCollider correctly assumes that new is the method you intended to put there. And at least in Qt GUI, if you're placing views on a window, you can omit the .view when specifying the parent space. And this works for Qt GUI, and I'm pretty sure this works for other GUI kits, but I'm not positive. So if you're using another kit, you can try it out for yourself and see if SuperCollider complains. Okay, so let's get a little bit more specific. At any given point in time, a GUI object has some state, which is often, but not always, some numerical value. And it's very often the case that we want to either retrieve and or alter this value. And this is most often referred to as getting and setting a value. We can get the state of our slider with the value message, which happens to be 0. And we can set the slider's value just like any other attribute with the underscore notation. By default, sliders and other number-based objects have a range of 0 to 1. Of course, we can also change the value simply by clicking and dragging the slider. Another very important feature of GUI objects is their action, which is a function that is evaluated whenever the user interacts with the object. Without specifying otherwise, an object's action is initially nil, which means no action is performed. We can change this by setting the action to be whatever function we like. So, now, whenever we interact with the slider, this function is evaluated. Now, in many cases, you'll want to somehow incorporate the instantaneous value of the slider into the output of the action function. And to do this, we declare an argument at the beginning of the action function. Of course, you can name this argument whatever you like, and SuperCollider interprets this argument as the instance of the GUI object itself. In this case, obj represents the slider. And so this declaration allows us to then access the slider's attributes within the action function. So to begin, let's simply post the value of the slider. So now each time we move the slider, the action function is evaluated, which prints the current value in the post window. And this brings us to another important method, which is value action with a capital A. Value action is a method that not only sets a new value, but also performs the action. Value action is distinct from value, which only gets or sets the value and does not perform the action. And so here's a quick demonstration. Value changes the state of the slider. Here I'm just choosing a random number, but we see no numerical value printed in the post window, which means the action is not invoked. Value action changes the state, but also performs the object's action, whatever that action might be. As we move forward, you'll see that this distinction is actually a very important one. Before we get too involved, I want to just briefly introduce some ways you can customize the appearance of GUI objects, colors in particular. And it's very natural to want to customize the color scheme and other visual aspects of your interface to give it a more personal feel. So here I often access the background attribute, which refers to the color of whatever is considered the background of that object. Background returns an instance of a class called color, which has 4 floating point inputs: red, green, blue, and alpha, which all range from 0 to 1. For the first 3 color values, 1 indicates full presence of that color, and 0 is total absence. For alpha, 1 means fully opaque, 0, transparent. Alpha is sometimes omitted, as it is here in the post window, and defaults to a value of 1. So let's change the slider background color. The most basic color method is .new, which, again, we're free to omit if we like. Here's a mix of full red, half green, and no blue. There are a few specific methods for common colors like .green, .magenta, and if we provide one input value for one of these methods, it's interpreted as an interpolation between full color and black. There's also color.rand, which chooses random RGB values based on a given minimum and maximum, which by default is between 0.3 and 0.9. And recall that the window space itself is also a type of view, which means we can change its background color too. So we could even do something totally ridiculous, like randomizing the background color whenever the slider's action is called. But I think most of us will agree this is a little extreme. We could do something similar but much more subtle by using color.new and incorporating some simple arithmetic to constrain these color values. Okay, so let's give our slider a blend of mostly blue and green with a little bit of red. We can also set the color of the slider's handle with the message knob color. Now it's white, and now it's black again. And we can also set the size of the slider handle with the message thumb size. So now it's 40 pixels, and now 20 pixels wide. Keep in mind that methods like knob color and thumb size aren't going to apply to every GUI object because they're all different from one another and some of them don't have knobs. So it's always a good idea to check the object's help file for specifics. And in fact, I often find myself going back to these help files periodically just to refresh my memory. Okay, so let's make this slider actually do something. So it's time to boot the audio server. Because we're focusing on GUI, I'm going to keep the audio fairly simple here and just have this slider control a center frequency of a bandpass filter. So first, a simple synth-def for filtering pink noise, in which we have an argument for the center frequency of the bandpass filter. And with that out of the way, now let's modify the slider's action. First of all, a range of 0 to 1 is totally inappropriate as the frequency input to a filter. So I'm going to declare a variable, call it CF, and map the slider's value from a linear range of 0 to 1 onto an exponential range of 100 to 4,000. Now, at this point, I want to point out that there is an object called control_spec, which is designed to map from one range and interpolation curve to another. But in all honesty, I don't actually use this object very much. Probably I should use it more, but I don't. So I'm not going to spend any more time on control_spec in this video, but I did want to mention it. And I do encourage you to look at the examples in the control_spec help file in case you might find it useful. So back to our example. Theoretically, we're going to have some synth running on the server. And for the sake of simplicity, when I create it, I'm just going to call it X. So the last step here is to update the frequency argument using the rescaled value. And finally, we create the synth. Okay, so it works. But this example actually has some problems. First of all, if we make a large instantaneous jump in the slider's value, we hear a horrible pop. Yeah, it's completely terrible. This is a consequence of controlling an otherwise continuous signal with discrete values that are not necessarily continuous. This kind of thing is actually especially prominent when dealing with filters. And I think one of the best solutions here involves changing the ugen function by lagging the frequency values. And .lag causes the signal to interpolate between successive values over a given time interval, which in effect translates the discrete data into a smoother stream of values. If the lag time is too short, the smoothing effect won't be strong enough to counteract the problem. But if the lag time is too long, the signal becomes really sluggish and unresponsive. So I'm going to specify half a second. So we can hear this is an improvement. Although the slider is not quite as responsive as before, we've gotten rid of that disgusting pop. Another problem with this example is that we're starting the synth with a default frequency of 440. But there's no guarantee that the value of the slider corresponds to this value. Like right now, for example, our slider is at the top of its range, so it actually corresponds to 4,000 hertz. This means if we start the synth, the initial sound won't match the initial state of the slider. We can correct this by initializing the frequency argument of the synth according to the slider's value, making sure to map the value onto the appropriate range. instead of starting and stopping the sound by evaluating code, let's introduce a new object, the button. And just like with the slider, we're going to start with the parent view and bounds. The button object is capable of having any number of states, and when the button is clicked, we cycle through these states. To start and stop sound with one button, we're essentially talking about a toggle button, which has two states. So how do we define a button's states? We provide an array containing as many internal arrays as the number of states we want, in this case 2. Each of these internal arrays will contain a string, the string color, and the background color. So state number 0 is the off state, and state number 1 is the on state. When the button's in state 1, let's give it the same background color as the slider. We can see that we've effectively created a button with 2 states, and we can also specify a jump to a particular state using the value message, very similar to what we did with slider. Any GUI object that involves text, such as the button, can have its typeface changed with the font message. We can set the font by providing an instance of a class simply called font. And again, I recommend taking some time to read through this help file to get a more thorough understanding. An instance of font needs 2 things: the name of the font, specified as a string, and the font size. But it's really important to remember that not everybody's going to have the same font library that you have. If you specify some bogus font, at best, SuperCollider is just going to go back to some default font choice. So, a personal recommendation here: don't let yourself get too carried away customizing fonts, or colors for that matter. I'll be first to admit that visually customizing an interface is a lot of fun, but I like to think of it as having dessert after slaving over a huge dinner. It can be really enjoyable, but it's not absolutely necessary, and sometimes I skip dessert altogether. Okay, so we've set up our button to have 2 states, and now we need to define its action. First things first, in the action function, we need to declare an argument in order to access the button instance itself, because we need to know the state of the button in order to determine whether we should be starting or stopping the sound. And so here, a conditional statement is in order. In plain English, if the button is on, start the sound. And if not, stop the sound. Okay, so for the most part, this is working. But watch what happens if I move the slider while the button is in the off position. Right. Node not found. The slider is trying to set values for a node that only exists when the button is on. Now you could probably imagine a variety of solutions to this problem. For example, you could disable the slider or make it invisible whenever the button is off. But I think the cleanest and simplest solution is to register the synth with an object called NodeWatcher. And we can read about this option in the help file for Node. Once a synth or group has been registered, NodeWatcher enables 2 methods, isPlaying and isRunning. And this is perfect for conditional statements. So here are the changes we need to make. When the synth is created, we simply append the message register, and that takes care of that. Then we want to include a conditional statement in the slider's action that will check to make sure that the synth exists before attempting to update its parameters. And now we can see that the failure messages we saw earlier are gone. Let's add a new object, a knob, to control the quality of the filter. So first we need to add a quality argument to the synth_def. And I'm also going to incorporate the quality argument into the filter's mul argument. Because when a filter's bandpass narrows, the amplitude decreases. And multiplying by this value will ensure that the amplitude will remain more or less constant, regardless of filter quality. And now we add the knob and give it an appropriate action function. and we want to make sure that the knob checks if the synth exists before trying to update its parameters. And also, we want to make sure that we incorporate the value of the knob when we create the synth. It's possible and sometimes desirable to have the action of one GUI object affect one or more other GUI objects. As a very simple example, let's create a number box that will reflect the value of the slider scaled to our frequency range of 100 to 4000 Hz. I'd like to put this number box right next to the slider. So the first thing I'm going to do is move the knob over to the right. And now for the number box, I will initialize the value at 100, and since this number represents the center frequency, I'm going to clip it within the range of the slider so that we don't accidentally get bad values. I'll keep the font consistent with the button font and limit the display to 2 decimal places. Again, all of these methods can be found in the help file. So the only parts that require some careful attention are the action functions. We want the slider to update the number box and vice versa, because they're both representing the same thing. So let's start with the slider. Whenever the slider's action is called, we want to update the value of the number box, making sure to rescale the values correctly. And we want to do more or less the same thing with the number box, except it's not enough to just call value on the slider. The slider is the object that is responsible for controlling the sound, so we actually need to call value action on the slider. However, what we don't want to do is to have both objects call value action on each other, because if this were the case, as soon as we interact with one of these two objects, they'll invoke each other's action back and forth, back and forth, back and forth, and this creates the dreaded infinite loop, and the interpreter will totally crash. So I find it useful to conceive of one GUI object in particular as being the active one, the one which sort of handles everything. And in this case, it's the slider which handles everything, controlling the sound and updating the other passive GUI objects, such as the number box. Any passive GUI objects are only responsible for relaying the action request to the one active GUI object and asking it to perform its function. Another object I use very often is called static text, and this is an ideal object for just labeling your other GUI objects with letters, numbers, words, and so forth. So I'm going to put a frequency label directly below the number box. String is probably the most important attribute, which determines the text that will be displayed. I'm going to keep the typeface consistent, and here's a new method. You can align the text within the object's bounds by providing a symbol, and usually this is going to be left, right, or center. Background we've seen before, and the text color is specified with the message string color. And now we have a label. If we don't specify colors, static text defaults to black text with a fully transparent background. And usually I prefer this default look, but I might start with an opaque background so I can actually see the boundaries of the object, and then later I'll make it transparent when I'm all done positioning everything. And now let's briefly talk about focusing. By default, some GUI objects are allowed to be in focus, and only one object can be in focus at a given time. If I bring the window itself into focus and then repeatedly press Tab, you should be able to see that I'm cycling focus through these 4 objects, in the order I've created them. Static text is the one exception here because static text, by default, does not focus. And you might even be able to see the faint blue outline that signifies when an object is in focus. Another way to focus one particular object, assuming it can focus, is to just click on it. When an object is in focus, certain default key actions become available. For example, let's focus the slider. Pressing C puts the slider at its center position, X at its maximum, pressing N puts it at its minimum, and pressing R chooses a random value. These 4 key actions also apply to the knob. And the arrow keys, too, often have actions associated with them, usually incrementing or decrementing the object. And modifier keys like Alt and Shift will often modify the arrow key or mouse behavior. Now, I discovered a lot of these default key actions by accident, so I encourage you to mess around to see what's actually possible. And when a button is in focus, pressing spacebar does the same thing as clicking with the mouse. Okay, so I can't show every GUI object, that would be ridiculous, but let me at least point out the objects that I tend to use more often than most. Pop-up menu provides a drop-down list of items. Range slider is similar to slider, but instead of one value, range slider has a minimum and maximum value that are independent of each other. Text field is a one-line text entry box. Text view is similar, but allows multiple lines of text. Slider 2D is a two-dimensional slider, pretty self-explanatory. And multi-slider view, again, the name is pretty self-explanatory. And then there are two others. Sound file view. This is a multi-featured object which is primarily used to display an audio waveform. And level indicator, which actually these objects on the meter window, these are all level indicators. And again, check out the help files for examples. Okay, so the last thing I'd like to cover has to do with workflow and efficiency. Now, something that really seems to turn people off from building graphical interfaces in SuperCollider is the sort of, tedious pixel hunting aspects. Now, I've been dropping objects onto my window pretty quickly, but of course I've prepared for this video, so I'm sort of cheating. Now, in SuperCollider, there's no native drag and drop environment for interface design. Now, of course, that's not to say you couldn't build such a thing yourself. In fact, maybe some people already have. And unless you've been blessed with godlike programming abilities, it's hard to deny that interface design is just going to be faster and more intuitive in something like PD or MaxMSP. And well, that's just the nature of how these environments are designed. So ultimately, if you're building an interface in SuperCollider, either it's going to take a little bit of time and you're going to have to do some degree of pixel hunting, or you just have to be okay with sloppy GUIs. Or there's the option that I prefer, which is planning things out in advance the old-fashioned way with pencil and graph paper. But there are a few tricks and features that can speed up your workflow quite a bit. One thing I've been doing already that you might have noticed is to put window.closeAll at the top of my primary clump of GUI code. And this prevents windows from piling up after multiple evaluations, which automatically avoids unnecessary clutter and things like that. Now with all the GUI code in one clump, I can make changes and then see those changes almost instantly. Like, okay, let's say, for example, I want to move this button so it's right snug next to the knob, and then tidy up the window so I don't have all this extra space. Now, I don't know the exact pixel values off the top of my head, but I can mess around until it looks right. So I'm going to start by just shifting the button to the left until it looks right. And now adjust the window size until that looks right. That looks pretty good. Now, okay, maybe this technique isn't quite as handy as some sort of drag and drop thing, but really it's not bad, and it's not really all that slow either, and with a little practice, this approach becomes pretty intuitive. But the real breadwinner when it comes to efficiency is the concept of decorators. A decorator can be assigned to a parent view and will govern how and where child views are positioned on it. As far as I know, there's currently only one type of decorator, called flow layout. And to show how flow layout works, I'm going to create a new window and introduce a few more concepts along the way. Okay, so here's our window. And once we create it, we then assign an instance of flow layout as the decorator of the main view. Flow layout takes 3 arguments. The first is an instance of rect to determine the bounds of the decorator space. And in pretty much every case, you'll want to apply this decorator to the entire parent view area, and so it's perfectly reasonable to just specify the bounds of the window itself. For the second and third arguments, we provide instances of a class called point. Point is an abstract representation of a point on the Cartesian plane. The second argument here is margin, which establishes a pixel border between the child views and the edges of the parent space. And the third argument is the gap, which determines the vertical and horizontal space between adjacent child views. So let's say a 15 by 15 pixel margin around the window, and the child views will be separated from their neighbors by 7 pixels horizontally and vertically. But before we actually evaluate this, there's actually a very nice syntax shortcut for point, which is simply x at y. So we can make these last two arguments much more compact. Okay, now for the fun part. Let's put a knob on the window. Now previously we had to specify an instance of rect for the object's bounds, but now because we're using flow layout, we only need to provide an instance of point, which determines the width and height of the object. Okay, not that impressive, but watch what happens when we run this line again several times. Flow layout essentially turns the parent view into a multi-line text field, but instead of text characters, we're dealing with GUI objects. Flow layout simply puts the next object to the right of the previous one and goes to the next line when it runs out of horizontal space. And flow layout is actually pretty smart about collisions in case the objects are not all the same size. We can force a new line by using the next line method on the instance of flow layout. And check this out, we can use iteration to add many objects at once. Notice there's a 15 by 15 border around the objects, and that the knobs themselves are spaced 7 pixels away from one another horizontally and vertically. So here's iteration to manipulate many objects at once. In this case, I'm randomizing the value of every child view. And iteration to remove multiple objects. If we add more objects at this point, we continue to defer to the decorator for XY positioning. The object in this case doesn't appear in the upper left corner like you might expect, so we can use the reset message on the decorator to start over. So that's the essence of flow layout, but this example is a little fast and loose, so I just want to show one more example and introduce the concept of subviews and nested layouts. So it's often a good idea when you're designing an interface to compartmentalize the various functionalities and then have the GUI reflect these conceptual divisions. For example, if you're designing some sort of synthesizer, you might have an oscillator section, a noise generator section, a filter section, and so forth. But each of these sections is probably going to have multiple GUI objects. So it's nice to be able to refer to one specific collection of GUI objects instead of having to refer to everything at once or refer to objects individually and give them all individual names. Now for this purpose, there are a couple of objects that simply behave as a parent view on which you can place more objects. One of these is called composite view, and this one I use fairly often to establish a little bit more of a meaningful hierarchy within the design of the interface. So in the following example, we have a window, and I'm assigning a flow layout to govern the placement of all immediate children with a 30 by 30 margin and gap. And then I'm going to fill an array with 4 composite views placed on the main view, each with a random background color, and each of these 4 subviews is going to get its own instance of flow layout, this time with a 5 by 5 margin and gap. So from here, let's say this upper left composite view will be my slider section. So again, for the purposes of convenient storage and access, I'll fill another array, this time fill it with 5 sliders. And let's put 8 knobs on the next composite view. And because we've stored these objects in arrays, it's actually very easy to refer to a specific object. For example, with the upper left composite view, let's access the middle slider, which is at index 2, and set its value to 0.5. Likewise, we can easily access all of the knobs simultaneously, like this. In any case, I hope this last example demonstrates that you can create and easily access many different GUI objects without having to type hundreds and hundreds of lines of code. That's all for tutorial 14. I really hope this tutorial helps to demystify the process of building a GUI in SuperCollider, and I hope it gives you some ideas for your own projects. Now I'm considering the possibility of returning to this topic in a future video to focus on building something a bit more complex and hopefully a bit more practical as well. In the meantime, please feel free to leave any comments or questions, And if you like these videos, I hope you'll consider subscribing. And as always, thanks so much for watching, and see you next time.